Okay, I've got a friend of mine who's in the lawn care business. There's lots of different things that you would do in a lawn care business. Mostly, you might work on small lawns or big lawns or do some raking. Now, when I describe things like a big lawn, apparently the price, at least at that time, was $50 for a big lawn. That a big lawn, by definition, is over 5,000 square feet. A small lawn was under 5,000 square feet and only charging $30. I think the prices may have changed since then, but regardless. Another thing that you might want to note is the zip code. When I say 12078, we know Gloversville, New York. It's not, the opposite is not always true. For instance, Schenectady has about 9 or 10 zip codes, Albany similarly. So if you know the zip code, you know the city and state. If you know the city and state, you don't necessarily know the zip code. So let's organize this stuff by entities. Some of this data relates to the person, that is the customer. So Andy Wilson lives on Main Street in Gloversville, and that's his phone number. And some of the things relate to today's job. This particular invoice on this particular date, he ordered one of whatever service ID number 1 is. Now, the service offered would also be grouped together. So that we're trying to group things by entity, so we can create an entity relationship diagram. Now, I pointed out this, if you know zip code, you know city and state, and that's why that could very easily be a separate table. We're going to start out that way, although we won't keep it that way. What we see here is the zip code is tied to both the person and the U.S. Postal Code service. So Andy Wilson lives in zip code 12078, which by definition means he lives in Gloversville, New York. So that's why those can be related. That'll be the common element. So we organize this as best we can. So perhaps we had zip code, city, and state in one grouping, and all this other stuff about the person over here. And so let's just organize our data. The person data going right here, the zip code data right there. The services that they offer are right here, and then today's transactions would go right here. So we're trying to get this organized. However, as I said, we need a zip in each if we're going to do that, but we only have about 10 records of customers, so we don't really need. The U.S. Postal Code would be several thousand records just related to that for what little we have. So we'll talk about that. But we've got service ID here tied to service ID there. So when we say you're going to choose service number 1 today, we would know what service number 1 is. And of course we need to add the customer, because without the customer we wouldn't know who's tied to what. So it looks like we've got it organized here, though it's not quite the way we want it. Let me explain. We're going to move the zip code over here to city, state, zip all in one, because as I mentioned, with only a few records, there's no point in having a huge database there. But that's not the real problem. The real problem relates to today's job right here. See, we need one invoice, but there could be multiple services. You might mow the lawn and rake the leaves on the same day. So that's the problem. We need multiple services. So we have to slip that out into 2 different tables. And that means the second table here, the details of it, is going to need the invoice ID in both. Now I can just move up the customer ID, and of course every table will have an ID of its own. So the invoice ID is not a unique identifier. This ID would be a unique identifier. And what we're going to end up with is a view very similar to this. The data will be a little different because I've updated the data tables, but we want to go back and recreate this view. Now by doing that, we're going to first upload the lawn.sql file. That'll be easy enough to do. We've done that before. And then we have to use the select. Now in this case, F name, address, city, state, zip. I did not put the table name because those are unique names, so it would know the table name. Normally I do it, but it's such a long SQL statement, I just chose not to do it this time. And of course I end up with I think 36 rows in this set. But what I really need to do is go back and add to that SQL statement, create view lawn as, in order to get the assignment to work.